Okay, guys, this video is going to be a little longer, but I really would like for you to watch the whole thing, okay? It's important, and it's kind of all we're going to be doing, talking about graphing radical equations, so I'd really like for you to get kind of this full picture. So, as we talked about in the last video, a radical equation is anything that involves, like, a radical, like this square root right here, right? And so sometimes we have radical functions, right? And that means we've got, like, an f of x or a y equals the square root of x. And so we can graph something like this, okay? And so what I want to think about when we graph it is what numbers, right, could we plug in for x and get a y value, okay? So what's going to happen if we plug in -1? What's the square root of -1? You guys know this, I, right? We can't graph I, or at least we're not graphing I on these coordinates, okay? So that's not an option for us. We can't have negative numbers in this graph. So where can we start? What's the square root of 0? 0. Then let's do easy numbers. The square root of, the square root of 1 is 1. The square root of 4 is 2. I'm just doing perfect squares on this side. Square root of 9 is 3. The square root of 16 is 4, and so on. And this is a table, right, that's going to represent these functions. And if we plug these in, I'll just be plugging like f of 4 is equal to the square root of 4, which is 2, right? So f of 4 is equal to 2, okay? And it turns out that this is the parent function. This right here is the parent function of the radical of the square root function. So this just the square root of x. And I want to show you just on, this is just a graph that I'm using, and I'm going to use the big grids as 1, okay, not the tiny grids, okay? Shows you what the parent function would look like. So it would start at 0, 0, and then we had 1, 1, and then we had what? 1, 2, 3, 4, 1, 2, and 4, 5, 6, 7, 8, 9, 1, 2, 3. So it's gonna look something like that, and it would almost look like maybe we've cut a quadratic function, a quadratic parent function. If you remember, it looked up and down, cut it in half and turned it sideways, and that's kind of what's going on here. But this is the parent function. I just wanted you to see it on a graph, okay? Then it turns out that there's another, this very similar to quadratics. There's like a form that we can look at for this, and it looks like this: y equals a, the square root of x minus h plus k. And this plus k is on the outside of the square root. Okay, so just looking at this, right, what do you think we can figure out about the graph from this? So you think about that for a second. And if you connect this back to vertex form of a quadratic, then you kind of recognize that maybe it's h and k. And so here we can identify that the vertex, or the starting point, is a better, I'm going to call this the starting point for us, okay, is hk, right? And then a is going to affect what? Maybe if a is negative, do you think it'll reflect over the x-axis, flip upside down? And you're probably right on some of this, right? And so what I want you to do to get an understanding of this, I'm going to show you where to go on Desmos, and I'm going to show you exactly what to type in, and we're going to play around with the graph a little bit, okay? So sorry about the noise, but I get my keyboard. Okay, so we're going to go to Desmos and see how this is affected on Desmos. Okay, and what's really cool is we're just going to type in that same form. So a, and then to find square root, you're going to have to come down here. Sorry. You're going to have to come down here and say show keyboard and use the square root right there. Okay, so square root, and then on the inside you're going to type. So a was our first, and then x minus h. You use your arrow key, and you could use this to get on the outside of it. Plus k, lowercase k, sorry. Then you see where it says add slider for a, h, and k. What it's recognizing in this is that those are variables that are going to change And we could, like in our original one, A was 1 and then H and K were 0, right? But we could change those. And so if you add that slider, click all, what's going to happen is it graphs that with all of those set to 1. But now you can grab this slider and you can say, okay, well, I don't want A to be 1. I want A to be 2, and I want to see what happens. And then you can come over here, and I want to zoom out a little so we can see more, right? And you can see what happens when A is 2. Or maybe we just said, what's going to happen when A is negative? Okay, well, it's getting closer, smaller. Now all of a sudden, A is negative, and what's going on? So here's A at -1, right? It's flipped upside down, reflected over the x-axis, just like we thought. And so play around. What I want you to do is just spend some time, maybe like 5 to 10 minutes tops, okay? Playing around and trying different combinations of H and K and A, and see how each of these variables affect. Okay, you can change them one at a time. Maybe even write an equation. Okay, so pick values for A, H, and K, and then predict what the graph will look like. And then you could set these sliders, okay, to whatever you decided and see if it's true. Okay, so that's kind of what I want you to do, just to get yourself comfortable with this before you go do the IXL. Okay, now remember, when you get ready to do the IXL, domain and range for a function, right? Domain's the input, range is the output. So if we have here domain, our input is our x value and our outputs are y. So for here, where does our domain start? When it was at 1, 1, right? H and K were at 1. Our domain started at 1 and it goes on forever. So anything greater than 1, right? And then x is greater than 1. And then our range, where does it start? It starts at, so our y value starts at 1 also for this. And so your IXL is going to ask you different questions about domain and range on this one. If, like I said, as always, if you have questions, just email me. And we can get it figured out. But I do want you to play around on this screen on Desmos for a while.